Okay, right. Almost there. Okay, right. Let me turn that volume down because that's ridiculous. And let me quickly copy the link. Copy that link and put it over here. Right, okay. Now, I don't know if you can see us yet, but anybody here yet? No, not yet. We're almost there. What a palaver. What a total palaver. Is Stu nearly with us? Let's see. Let's quickly. There we go. Right. Hopefully this is going to work. Telling me the meeting link is not valid. I'll send it to you again, Stu. Oh, I love it when things go really well. Right, let's invite you. Copy invitation. Pop it in there. And off we go. Something's telling us not to do this. I don't know what. Anyone here yet? No. Right, let me close that. Okay, right. Are you with us? Oh no, don't know. Ah, that's not what I meant to copy at all. Right, let's admit Stu. No, don't. And then Stu, are you here? Are you here, Stu? He's almost here. Stu, can you hear me? Stu. Hello.
Hello. Right. I can
you hear me?
I can hear you. I can hear you. Yes.
Stu, let me just turn the volume down on this. Oh, Stu. Hey, Andrew's here. Claire's here. Brilliant. Hello. How are you, Stu?
I'm good, thank you. Yes. Yes.
What a palaver,
all
eh?
I can see, you see, all I can see is you. I can't see, I can't see anybody else, who else is joining.
Well, that's okay.
I can view the stream on YouTube. Will that help me know who's
no.
around?
Claire's here. James here. We do have the Ghostbusters Firehouse. Thank you for spotting it. It's not actually mine. It's my children's. Oh, Stu! It only took us 18 minutes to get over here. That's kind of okay, isn't it?
There we go. Right. Okay.
Stu.
That all got very, very confusing because I clicked on the YouTube link, and there's a good 5-second delay between what I'm hearing and seeing on Zoom and what's going on YouTube, and that was
don't look at that.
brain.
Don't look at that. That's fine. I'll keep an eye on the questions and people saying hello. So Claire's here. I'm going to say Jamie. Is it Jamie? If it's not, I'm really sorry. And Andrew's here, and a few more people joining now. Excellent. Stu, Dr. Stu, how are you?
Yeah, I'm fine. I'm good.
That was just the start you envisaged, wasn't it, for the Stuniverse Live?
Like a dream. It started like a dream.
Like a well-oiled machine.
Yeah, like we'd never been away.
How well-oiled would you say you are at the moment? Not right now, but how well-oiled would you say you are in general? Are you are you self-medicating through lockdown? Is what I'm
I
trying
did. Well, I did have. I did have a glass of wine at about 7 o'clock. So
to. What already? No wonder this has gone to tur.
it's not the reason.
You're off your face. I'm still sort of mainly sober. I've had 2 nights of having a drink since New Year, and
How many drinks in those nights?
58,000.
Yeah,
Well,
I do seem to remember one morning after where you said you'd drunk everything.
yeah, and just because I did,
Yeah,
So, Dr. Stu, I know who you are. Lots of the people joining us know who you are, but just in case they don't know who you are, hello, Chris. Who are you? What do you do?
You're not the first to ask that question.
No, I know I'm not.
Well, so yes, I studied astronomy at university, and have always been fascinated by stories and writing. And so my career has been writing about space and astronomy and the big issues like that. So
And let's be honest, explaining it to idiots like me.
yeah, I mean, I love I love the that satisfaction and that wonder of understanding something. It just, makes it amazing. And I think, I mean, we're only just starting this, and it's so easy to go so over the top with these kinds of things. But the idea, that we can look out into the universe and never get to these objects, and yet we can have good ideas, sometimes even virtual certainty about what they're doing, what they are, how we fit into all of that. I mean, that is just a miraculous thing for me.
You're sort of describing my lockdown as well.
I'm just looking at all
And
these
now
things
just
going
looking
on
out the
around you,
window, all these things
wondering.
I can't interact with, just wondering, what are they? Do they feel like I feel?
Yeah, you see, so if lockdown's teaching you anything, it's the actual mindset of most astronomers.
Of course it is, because this is kind of what they do, isn't it? Is it? I don't know. I'm just going to change my lighting slightly. Yeah, because they're all on their lonesome, aren't they?
Mostly.
Apart
For
from
good, well, for
with the
good
other,
reason in a lot of cases.
with the other spacemen, of course, and women in their international space station. It is still up there, isn't it?
Oh yeah. I mean, gosh, permanently manned now for decades. Yes.
Excellent.
Quite astonishing, really, that there's a permanent human presence in space, and of course, the emphasis is on trying to get back to the moon, well, by 2024. But I think that's
And
super ambitious, to be
we're going to
honest.
talk about that a bit later, aren't we? Because there's plans afoot.
There are indeed. Yep, there are indeed.
Just in case, if you is that where Bowie went? Yes, it is. It is where Bowie went, and we all know that as soon as Bowie went, everything went. Basically, it shouldn't swear, but it did. So basically, Stu and I we've been friends for what, over 20 years? It must be well over 20 years now. And what was that?
I didn't say anything. I just, it doesn't seem like a day over 30.
Yeah. No, it doesn't. It doesn't, does it? We could probably call it a day soon. Just say, do you know what? We've had a good run. We've given it our best, but it's just not working out for either of us. So basically, we've been friends for a very long time, and what we still do, not just me, but our other friends, all our mutual friends as well, is we love basically asking Dr. Stu to explain things to us. So a few years ago, Stu and I used to do a podcast called the Stuniverse. It's still out there, I think, on the podcast places that you can go to. But we thought during lockdown we'll do a little live one. What we hadn't thought about is giving it a dummy run between the two of us. beforehand, which is why we're no longer on Twitter. We're instead over here in nice YouTube land. But yeah, so now someone's asked about Elon Musk, but I know we're going to come to that. So just going to go to my notes. Hang on, talk amongst yourself. 30 years.
I listened back to some of the early Stuniverses this afternoon.
Did you?
Yeah, well, I thought I really ought to work out, also remind myself what it is we used to do.
Just really short things to do today.
Yeah, not actually, but yeah. I had to remind myself how we played the game Big Fat Galactic Liar.
Well, because we're going to give it a go later, aren't we? I'm still trying to get my lighting right. That's ridiculous. Let's face it.
That's a bit scary, actually.
It looks like they've come to get me. So tell us first of all, and by the way, you can ask questions at any time. In fact, shall we? No, we'll keep that for a moment because we're going to come to it. But can you tell us quickly about a 30th birthday that's happening? Is it now or soon or around about now?
Yes, it is. Officially, it'll be happening on Friday.
Oh, it's like really, really close then.
Yeah, absolutely. And so you still got time to get a card in the post. It's for the Hubble Space Telescope. Yeah, it's 30 years old, and who'd have thought it, eh?
And right, at the risk of sounding stupid, a space telescope is one that's in space, right?
That you're so sharp.
Yeah. As opposed to, I'll show you my Christmas present later. It's just there, a non-space telescope. So I think I remember being, because I would have been at school when it went up. What was it sent up into space for? I mean, to look at stuff. I know that much, but
yeah. So I mean, the idea behind the space telescope is simply that starlight and light throughout the universe, it can travel through billions of light years of space in a virtually pristine condition, and then it gets to within about 100 kilometers of the telescopes on the ground, and the atmosphere of the Earth just mucks the image up completely.
Is it up? It's come all that way, and
yeah, exactly. And it's that effect, that atmospheric effect, that causes the twinkling of the stars that we see in the night sky. That's all the air pockets moving around in the atmosphere and just distorting all the starlight.
No, it isn't. It's the carpet. It's the carpet of the universe, just gently shimmying in the space wind.
You can think of it that way if that
makes
you happy.
I do.
And so the idea simply was, right from the very sort of first years of the space race, is that if you could put a telescope in space, you could see the stars and all the other celestial objects just so much better than you can on the Earth. And so despite the fact that the conversations about doing this started in the early 60s, it took until 1990 for an actual space telescope, the Hubble Space Telescope, a large-scale general observatory to be taken into space and launched into space.
So sorry, it's an observatory.
Yes, in the sense that it has a number of different instruments that can all use the same telescope.
Bassoon.
Not a bassoon, wrong kind of instruments. And that astronomers simply they look at the technical specifications for the telescope, what it can do, what it can see, and then they just use their imaginations for what scientific investigations they want to do with it. And then twice or however many times a year, all those applications come in. The time allocation committee go through all of those, and the best proposals get time on the telescope. So it's a truly general purpose instrument. Okay.
So, but even now, people can go, "Oh, I tell you what's a good idea. Why don't we use it for that?" Has anyone ever tried to? Has anyone ever suggested turning it around and trying to set light to Denmark or something?
What's set light? What, like as in
like
using a magnifying glass?
Yeah. Would that work?
Strangely enough, no.
You're a bit of a naysayer, I doubt it's even been tried, Stu.
Let's be honest. You're right there. Yes.
Yes. Good.
You are right there.
Nicola wants to know, why doesn't it just float away?
So it's in orbit around the Earth, and what that means is that it's been launched with such a large velocity that it doesn't fall back to Earth. It's still going fast enough that it can resist the pull of the Earth's gravity, but not fast enough that it escapes from the gravitational influence of the Earth completely.
So, but what? So does that mean that whoever's controlling it with a joystick in Florida somewhere? I know it probably isn't that. Is able to go, or just speed it up a bit, or slow it down a bit. Is that what's happening?
No, it has no
Mark, no.
engines on it.
Right.
So you're frictionless in space. So once you're in orbit, essentially you're there forever. Essentially, because you're falling. So here's the thing: the Earth is a curve, and you're going super fast in that direction.
Yeah.
The gravity is still pulling you down though from the
Yeah.
Earth's center, and you're falling at exactly the same rate at which the Earth's surface is curving away from you.
But why are you falling at that exact rate?
Because the gravity of the Earth is still pulling you.
Okay.
But you never slow down because it's frictionless. So you constantly maintain this sort of force, this sort of velocity along, and the force always acting at a right angle downwards, and that's just curving you around. That's what gives you circular motion. These sort of right angle directed forces.
It all just seems like a bit too convenient.
It's not. It's just physics.
Oh, it's just physics, everyone.
Physics.
Physics. Richard says, hello. Oh, it's Richard Hyde, old friend of ours.
Yes.
Hello, I'm here and I'm a Virgo.
No one is in any way surprised.
Well, exactly, yeah. And it's not, it's must be the first time someone's made a joke about you being an astronomer as opposed to an astrologer, isn't it?
I can't even believe you've made that joke.
I didn't. It was Richard. It was Richard. It wasn't even me. So there you go. Shows what you know. Right. Okay. Nicola's well on top of this. She wants to know, are there loads of lost kites up there too?
No.
What happened to old Baumgartner's big balloon? You remember he took himself up there. What happened to that?
That will have come down, I suppose. Yeah, I mean, it's the balloons never go high enough or fast enough to be able to sort of go into orbit.
It was a big balloon, though.
Yeah, it's going to come down though. What goes up comes down.
Yeah, that's right, Mark. Well done, Mark. So happy birthday, Hubble Space Telescope, then.
Yeah, it's quite astonishing, really. 30 years. And I would say there's no part of astronomy that it's not touched, that it's not revolutionized, or shown us somewhere that something super interesting about. In some cases, just completely rewritten the textbooks. So it is an extraordinary telescope.
And yet, still no one has used it to turn it around and try and set light to Denmark or any other small Scandinavian country. It's not that small, Denmark, actually, is it? That's probably the smallest of the Scandinavian countries.
If you say so. I'm the astronomer, not the geographer.
You've been to a Scandinavian country, haven't you, Stu?
Good link. Yes, I have. I've been to several.
I remember a few years ago you went to give some lectures, didn't you, on the Aurora Borealis?
Here we go.
The Northern Lights, as it's known in Philip Pullman's slang.
I did.
Yeah.
Went up to the Arctic Circle there.
Was it your first time up in the Arctic Circle?
It was actually. Yeah, I'll tell you what. It's cold.
Yeah, no, I've heard that.
Mm.
So your first time, so just for everyone's benefit, first time in the Arctic Circle, you were there as an expert. giving lectures on the Aurora Borealis. And did you?
Yeah, I know where you're going with this.
Did you happen to see it, Stu? Or
no?
What? Really? What, you mean it didn't appear while you were there?
No, it did appear. Yes, the 2 weeks that I was there, I went twice, and the first week I went, absolutely nothing, just a total no-show. And then the next time I went, my plane was horrendously delayed, and there was some sort of oh gosh, where did we stop? We stopped at Oslo, I think, and had to have the plane repaired because there was some sort of problem actually with the plane. So we were just there for hours and hours.
That's not what you want, is it?
It wasn't exactly what you want. So didn't get didn't get up to Tromsø until the really early hours of the morning, and managed to get through the next day, and then just completely crashed that night. And that was the night that the Northern Lights showed.
And all the people that had paid money to be up there hearing lectures from experts, they were all out there, weren't they, watching it?
They were having a big party, apparently, out just under my window, trying to wake me up. And I was dead to the world. So
amazing.
Still.
Amazing.
They got their lecture. They got to see the Northern Lights.
Well, there you go. You can't ask for more than that, can you? David earlier wanted to know all about Elon Musk. And just while we do that, I just need to do this. What can you tell us about old Elon? What's going on with him?
Well, he's a car, isn't he? Sort of interesting and sort of very troubling.
I'm on board. You got me.
Because the Starlink satellites are designed to bring the internet everywhere, so that there'll be satellite internet connections everywhere. So a great thing to increase connectivity over the whole world. The problem comes from the fact that these satellites, there will be thousands upon thousands of them to give the correct global coverage. And under the correct conditions, they can reflect starlight or sunlight, sorry, when they're in the night sky. And this ruins the view for astronomers. And when I say ruins the view, I don't just mean that it gets in the way or just is a momentary disturbance, but it can ruin data because they're so bright that if you're taking an exposure of a very important celestial object that may take minutes or hours to gain that exposure, one of these Starlink satellites passing across the field of view can saturate the CCD chip and just ruin the exposure completely. So the fact that there's going to be thousands of them up there is a cause for huge concern, actually.
Thousands?
Thousands. They're small sort of CubeSat type things.
How big are we talking about?
Sort of these sorts of sizes.
Really?
Yeah, and there's another load going up in about half an hour or so. Another launch today that's going up. And
does he have to get permission to do this, or can he just?
Yeah, so you can't launch anything without permission. The permissions have been given, perhaps without the necessary scrutiny as to what is actually going on. Now, I would say that he's SpaceX and Elon Musk. He's working with astronomers, and there are trial coatings on the satellites to try and not make them so reflective, and what have you. But I think it is a proper concern. Now there is a pass later tonight. Let me look that up. So at about 9:34 this evening, a Starlink train will pass from west to east.
I'm sorry, a Starlink train?
Yeah, and a load of the satellites. See them. You just see them passing across the sky.
In a line, or just?
In a line, yes.
Yeah.
They go from west to east.
Right.
And the best way to locate west at the moment is to look for the brightest thing in the sky,
Is that Venus?
which is Venus. That is absolutely right.
Mhm.
The maximum sort of altitude that the satellites will get tonight is 75 degrees. So that's really quite high up, and they'll sweep across from Venus round over into the west. So you'll be able to see them. There's been some concern over the last couple of nights because there have been passes every night,
Right.
but the last 2 nights they haven't actually been visible because they've been taking place just after 10 o'clock, and the angle between the sun and the Starlink
Okay.
cluster
It's not right.
isn't right for the reflection. Tonight, between about 9:30, they could be quite bright. And then on Friday, there could be an even brighter pass at 9:10. So
Oh,
I'll
well,
give you a little bit of a sort of idea of the scale of the problem.
I'm going to be out there later. Nick actually asked, Jamie's been watching Starlinks going overhead this week, says they're amazing. Nick's said, too much stuff in orbit. Is there a real danger that collisions between 60 years worth of orbiting debris will cause a cloud of small particles?
It's a massive problem.
Oh, not even a little problem.
No, not even a little problem. It's a massive problem. So in the 70s, an engineer called Kessler showed what would happen. And the problem with it is, so we're all very used now to talking about exponential growth with the virus and the pandemic.
Yeah.
So in the case of, say, the virus, one infectious person is likely to infect an average of 2.5 other people. So, and that rapidly builds up. So over the course of a week, if you don't stay inside and you have the virus, you're probably going to infect cause about 100 other infections with the people that you interact with, the people that they interact with, and so on. With space debris, if you have a collision between 2 objects, then you create tens of thousands of other pieces of space debris.
Just with 2 objects?
Just with 2 objects. You use 2 satellites collide, creates tens of thousands of bits of debris. And at the speeds at which they're going in orbit, a nut, from a nut and bolt, something like that, if it hits another object, the velocity will mean that it hits with the energy equivalent of a hand grenade going off, which will cause tens of thousands of other pieces of debris capable of this. So this is hyper exponential growth in the space debris conditions. And we've had 2 serious collisions. So one was a collision between a communication satellite owned by the Iridium company in the US and a defunct Russian spy sat. And they collided and created a huge debris cloud. Then, because in the 90s, late 90s, early 2000s, because America would not sign these international agreements about not to put weapons in space, the Chinese destroyed one of their satellites in orbit, one of their old weather satellites. They shot it down. They just launched a missile from Earth to show that they could shoot down anything.
Someone going, I know how to get rid of that.
Yes, exactly. So what they're saying, okay, you say you're not signing up to not putting weapons in space, fine, but look, we'll just show you we can shoot down anything you put up there anyway. Unbelievably irresponsible act from the point of view of the space debris that it created. And this hyper exponential inflation is known as the Kessler syndrome. And I mean, I don't know a single person that, if they actually think about it, doesn't lose sleep over this, because the potential to lose access to space and orbits and just take out, so so many satellites take out the GPS system and things like that. It's real, and one of the biggest concerns. So there's a lot of work being done on how to stop creating space debris with when your satellite dies, how do you get rid of it? You re-enter it, or you put it into a safe orbit somewhere else, and then just park it somewhere. These sort of and other ways of actually trying to remove space debris, which is something that we're going to have to start doing in the next 10 years.
Claire wanted to know if any of this puts the International Space Station at risk.
Oh, absolutely. They're moving it out of the way of space debris several times a year, I would say, maybe even more. So these collision avoidance maneuvers now go on for all active satellites.
Right.
And whereas before, it wasn't a concern at all, now it's constantly being monitored, and things are being moved. It has a terrible name attached to it. It's called Space Situational Awareness, or SSA. Yeah, and everyone is doing it, and everyone knows what a big problem this is.
Well, I'm going to admit to not realising what a huge problem it was until you've mentioned it this evening. I'll tell you what I want to ask quickly. What is Elon's plan with all of these? He wants to kind of increase internet-y communications with his satellites, because at the moment, and this was a huge surprise to me when I found out, we were doing some research on another project, weren't we? And you probably already knew this, but it's only a tiny percentage of the world's communications, like data for the internet, that goes through satellites. It's mostly zipping around on undersea cables, isn't it? Like 99%, something ridiculously high.
Yes, I forget the exact percentage of it now, but it's super high. It's quite surprisingly high as well. But Elon's game plan really is to be able to supply the internet no matter where you are in the world.
What, even Norfolk?
Even Norfolk.
Imagine that. Imagine that. Just trying to imagine living in Norfolk as well.
I've heard it's very nice.
It's nice. Yeah, it's nice to visit, and I'm sure it's lovely to live in. Actually, Norwich, very nice city. Right, what Planet 9? What is that?
Oh, this is a nice little result that came out this week, actually. So there's been speculation for many, many years about whether there are more planets beyond Neptune, beyond Uranus, sort of way out into the outer solar system.
Oh, in our solar system, right?
In our actual solar system, whether we have planets that we just simply can't see because they're so far away. So we're talking hundreds of times the distance that the Earth is from the sun, something extreme like that. And all the planets that we know of are within about 30 times the distance of the Earth from the sun. And there seemed to be these smaller objects out there called the trans-Neptunian objects, and they're just like big icy asteroids, really, or slightly bigger than that. They're sort of dwarf planets, if you like.
Right.
And for a number of years, it's been looking like there's been a strange alignment in them, which could be the signs of the gravitational sort of field corralling them of this potential Planet 9. But this week, some astronomers published a bigger survey of the data. And bad news for Planet 9 is that it seems to have gone away. We were just looking at a slightly biased sample of the data first, and if you look at more widely, it doesn't seem to be there. So it's a bit of a setback for Planet 9, but hopefully, maybe we'll still find something out there.
Good for the other planets. Less attention taken away from them.
Absolutely right.
Well, do you think there are other planets in our solar system?
I tell you what's really interesting for me, and and that is that we have these two classes of comets. We have the comets, like Halley's comet, which are these short period comets, they're called, and they return to the inner solar system in the space of 100 years or so, something like that.
Someone asked about that earlier, if it was still up there. It is still up there.
Oh yeah, yeah. Halley's comet is still there. Gosh, when does it come back? 2060, 2061, something like that, is when Halley's comet will return the next time.
It's definitely time to make a quick cup of tea.
Yeah.
Get yourself set.
Yeah. It's like, it's sometime in the 2060s. Okay. And then we have these other comets that come from much further away, and those are called the long period comets. So you have the short period and the long period comets, and the ones that come from very far away, their orbital periods can be tens of thousands of years. So I've always wondered why we don't have comets that have orbital periods of sort of many hundreds of years or a couple of thousand of years. Because you would imagine that the reservoir of comets is sort of everywhere and all around. And that makes me wonder whether there is some other planet or several other planets that are in that sort of region. So thousands of times the distance of the Earth from the sun, but still gravitationally bound to the sun, and in vast orbits which would take thousands or even tens of thousands of years to complete their orbits. But they've gravitationally cleared out that region of space. And they'd be super hard to find because they'd be reflecting nothing but starlight. So they would really struggle to see them.
Well, wait, when you say cleared out that area of space, what?
In the sense that if they're passing, they will sort of gravitationally perturb any of the comets that are out there, and that sort of knocks them out the way and gets rid of them, which is why we don't have. Say that again, Mark.
Give it a bit of a look as it goes past.
Yeah, just.
This is my impression of a planet, by the way. Clearing out a reservoir. Hold on. Got permission to be here. It's really good, isn't it? I mean, honestly,
it's convinced me.
On board, I reckon. Sorry, I made a silly point. So they've cleared out all the comets. So and zone.
Yeah, and so that it does make me wonder if there's more out there to be found. And we have a large number of survey telescopes that are being built at the moment. I mean, really large ones. There's one called the Large Synoptic Survey Telescope. I think it's just been renamed actually to the Vera Rubin telescope.
I was going to say, yeah, probably that's probably the next logical name.
Obviously.
Yeah.
And that might glimpse these planets, So it's a really interesting time for looking for Planet 9.
So this thing happens whenever I speak to you, Stu, and I've told you before, but my brain actually starts hurting a little bit.
That's usually when we end these things.
Yeah, and no bad thing really, but my brain, it does when you try and sort of get some kind of mind handle on the vastness of it. Does it hurt your brain? Does it make you kind of go a bit giddy, or you're just too clever?
No, it's not that at all. It's a willingness to be in that mind-blown space. I think I get, I get a sort of a feeling of pleasure out of it, in that sense that there's these things that are just so big and so vast that it's awesome. That's my feeling of it. It gives me feelings of awe and inspiration.
Well, I'm not surprised. I think, given that we came a bit late to this, that we should probably do one more little bit.
Mm-hmm.
Some people have sent in some people are sending in questions right now. So should we do that, and then maybe we'll call it a night there, and then maybe do this again, but kind of knowing how to do it this time.
I think it's a super good idea.
So Andrew wanted to know what are the real world chances of a solar flare taking out a lot of satellites? Are they protected against flares?
So there is protection on the satellites. There are things that you can do with them to try to stop the electricity getting into them, which is essentially what happens in a solar storm. You create short circuits in the spacecraft and fry the electric circuits. The chances of a big solar flare happening are well, they're large. So if you take any one of these other sort of apocalyptic astronomical scenarios, like an asteroid hitting the Earth, something like that, that's gosh, that's once in a big one that's really serious. You're talking 1,000 years or something like that, 1 in 1,000 years or longer.
Are we due one?
Not really, and we're doing pretty well at finding the really big ones. So we know quite a lot of the. There's nothing out there that's going to cause something like the extinction of the dinosaurs that we know of, and we're sort of gradually getting down into the smaller sort of city killer sort of size of asteroids and surveying those.
I love the way you said that. The smaller city killer.
It does have to hit a city, and there's the chances of that are very small as well. And in that sense, you see, the chances of a big solar flare are much more likely. You're talking big flares, every century, every 50 years, something like that.
Right.
And now, sometimes, of course, the big ones that took place in 2003, they happened to be directed. The biggest one happened to be directed away from the Earth, so we didn't get a hit from that. But we had this huge hit in 1859, on September the 2nd, 1859. That was the Carrington flare. And
sounds like a dance.
and the Carrington flare that took out global communications and global navigation systems as they were in the 19th century, which were compasses and the telegraph network. So the compasses all spun uselessly. The telegraph system, the phantom electricity from the aurora and the solar storm just flowed along the wires. It stunned telegraph operators unconscious. Telegraph offices burst into flames. It was pretty big stuff. And if you had something that size today, that would be serious.
Right, so that's going to knock out all our mobiles and.
Well, here's the thing that you see it coming. You get about 18 hours warning.
That's good of it.
Because you see, isn't it? Yeah. So you see the flare take place on the sun. It has to be sort of very close to the central meridian line of the sun, so it's actually sort of heading directly for you. And then you turn off as much as you possibly can. It's sort of that simple, really.
You just go around doing what my dad used to do every evening, just turning everything off.
That is exactly what you do. That's exactly what you do. The problem is the power grids. So you could say you might be able to turn off and put into safe mode a lot of the satellites. The problems that you have is the power grids on the Earth. Because like the telegraph system used to rely on just hugely long telegraph wires, the power transmission system now relies on hugely long wires and power lines, and they will pick up the induced electricity from the solar storm. It will hit the magnetic field of the Earth, which will cause the magnetic field to be pushed down towards the surface of the planet. And if you remember in your science lessons at school, hooking up a wire to an ammeter and
Yeah.
waving a magnet around beside the wire and watching the current start to flow through the wire. That's what happens. It's just that it's the magnetic field of the Earth that's being buffeted to and from across the wires. And so the power grid is the one that's at risk mostly. But it's a known problem. Lots of people are sort of working on it, and hopefully we'll be able to sort of protect those in time as well.
Just pull a big tarpaulin over it really quickly.
Just get everyone to stop watching telly.
Yeah, oh, you could do that. By the way, you may be able to see, or indeed hear, one of our cats has come in for a bit of food. So that's just happening in the background there. Nice to give it, make it seem real, authentic. I've got a question for you quickly.
Okay.
Could the coronavirus survive in space?
Well, this is super interesting.
And you didn't ask this, did you? You didn't know. I didn't give you any more.
So before we go any further, this does not mean that the coronavirus has come from space.
Until I see evidence otherwise, everything's on the table as far as I'm concerned.
In a sense, why not? It's a virus. It's a large molecule, and the thing that makes me say that is because we know from some of the equipment that was sent to the moon, the early spacecraft that was sent to the moon. I'm thinking specifically of a camera on Surveyor 2. Oh gosh, which one was it? Was it Apollo 12? I think the astronauts landed quite near that spacecraft, and they went and they unbolted bits of equipment from it, cameras and things like that, and brought them back to Earth to see how they had survived, what the space environment and those years on the lunar surface had done to them. And what they found was bacteria in one of the cameras, viable bacteria. So not a virus, but a more complex thing, a living cell that had somehow got in there, that it wasn't sterilized correctly when they built it, and had survived in this airless, radiation-filled, vacuum of space. So the movement of even living cells between planetary bodies is possible.
I'm sort of sorry I asked that now. I'll be honest. I'm going to ask one more question. Yes, and then we'll say goodbye for this evening. Does that sound all right with you?
That's good. That's good with me.
Nick wants to know, are all the objects that orbit the sun on the same axis, the same orbital plane as the planets?
So not all of them. Now, most of them are. And this tells us something about the way that the solar system formed. And these long period comets that we were talking about beforehand, they're in random directions. They come at us from all angles. It's one of their defining features. But most of the natural bodies in the solar system, yes, they're confined more or less to the same plane, which is a bit similar. It's the ecliptic plane, if you like. It's called the ecliptic.
So why are they all like that?
So it's because you when the solar system forms, you can start with a spherical cloud.
Yeah.
And then gravity starts to pull it together.
Okay.
So it starts to pull it towards a central point. Now, if the cloud has any degree of rotation to it, and it will, there's just no way it can't. It means that as it falls together, angular momentum will be conserved, so it will spin faster.
Right. Okay.
And okay, so if you're spinning in this direction, around this way, then it will get faster in this direction, which will cause an outward force, the centrifugal force, to push outwards. So that supports the equatorial regions of the cloud, but at the poles where gravity is still pulling it down, but you don't have so much rotational angular momentum, it pancakes. There's nothing to resist the collapse. And so any three-dimensional shape that rotates and also collapses will naturally pancake, and that gives us the plane of the solar system.
And is that what it's called, pancaking?
In my head, that is what it's called.
Well, if that lot at NASA aren't saying that, they should be.
I agree.
We made it work eventually. We made it work eventually, despite our false start. But I've really enjoyed that. I hope you've enjoyed it. All you people still watching, thank you for coming over.
Yeah, thank you so much, everyone.
Maybe we'll do it again, and maybe if in the meantime you've got any questions that you want Dr. Stu to answer, probably don't send them to me. I don't know. Well, I mean, you know, copy me in because it'd be nice to know what it's talking about. But yeah, just what's your Twitter? What's your Twitter name?
At Dr. Stu Clark, so DrStuClark.
Brilliant. And I'm Mark O'Sullivan, all one word, all lowercase, no apostrophes. Anyway, oh look, people have enjoyed it. That's nice. Well,
thank you, everyone. Really, really appreciate it.
And we'll make it work without the drama next time. What are you doing? Anything tonight?
I think I'll go and have another glass of wine.
Why not? You treat yourself. I think you deserve it now.
And you too, even though you're not drinking.
I know, yeah. Right. Thank you so much. We'll speak again. Take care.
Yeah. Take care, everyone. Take care, Mark, and stay safe.
Bye. Bye.